think she's ever lost.
All right, so we're looking at worksheet 16 right now in your packet, and it basically states, like, go look at your book. I know you don't have a book in front of you, so I have some problems for you to write down. We're going to skip around a little bit, though, so we can focus on what's actually on your test coming up here. So, first thing I'd like you to do is... you don't have to write this one down necessarily. Like, don't write down the problem, but there's a lot of space on number 19 on this worksheet, and above it, we obviously skipped all those, so you can use all that space to write down some setup for me. I don't even want you guys to do any calculation. I just want you to throw the pieces into the formula where they belong. That's it. So, on worksheet 16A, there's a space for 19. You don't need to write down this whole problem, though. Okay, so we have a principal that is given to you as $250. You have an interest rate of 7%. You have a time of 6 years. And what they're going to have you do is they're going to have you change the amount of times that you collect interest. So, when n equals 1, part of the trouble for kids is they don't necessarily know which formula to use. So I would argue when I look at my formula card that you guys get to use on the test, that this formula and this formula are actually the same formula. But the difference is you don't see them dividing by an n and multiplying by an n in this initial version. And that's because this is the one that you guys use when you just compound or collect one time per interval. So it would be silly for you to be like, divide by 1, because no one does that in math. And it would be silly for you to say multiply by 1, because no one does that in math either. So technically, same formula. This one just has multiple compoundings within the time period, and that's why it divides and multiplies by n. So when n equals 1, you can use the simpler version of it, right? So you'd set up a 250 times 1 plus your rate of 0.07. Since you're dividing by 1, you don't need to do that part. And then to the 6th power. So are we all okay just knowing how to set that one up properly? That would be this guy. Now, what if I have you skip ahead and look at the setup for 12 times a year? Now I do have to use this more elaborate compounding formula. So still 250. Still 1 plus, still a rate of 0.07. But because we're compounding 12 times a year, and I only saw a couple people make this backwards on their last test, remember it's divided by how many times, so that would be a 12. And then the 12 shows up here in the exponent again, multiplied by 6. This question also, by the way, could be done on a TVM solver on your app on your calculator. The only difference is when it asks you for a payment, because you're not paying monthly things, you keep payment as 0. So some kids just really like TVM, so they just use it for everything. That's fine. You wouldn't be able to use it for this guy, though. Continual interest. What formula am I supposed to use when it says it compounds continuously? Starts off the same, ends up not, but then instead of 1 plus r, your base is e. Continual interest is part, right? E to the RT power. So we'd set up 250. This one's no word, yes. 250 times, I don't need parentheses, what am I doing? Anyways, e to the positive 0.07 times 6 power. When would I make this rate a negative? Because there are times in PreCalc where we've created a negative rate up here. Because it's decreasing. So like you see a negative rate when we're doing Newton's law questions because it's cooling.
Or if they're taking the money away.
Or if we're decreasing the money, yep, that's exactly right. Or if some population is decaying, yep. You got it.
Wait, depreciation would be
decaying.
Per, right?
No, not necessarily. Just it would be a subtracted rate, a negative rate. Depreciation. If it said continual depreciation, you'd use per.
I thought depreciation was continual.
Not always. It says depreciating at a monthly rate or something.
Oh.
So you got to watch the compounding word.
So just curious, so say you buy a car.
Mm-hmm.
And
that's usually annual depreciation.
Okay, is it written into like something telling you how often it's going to depreciate?
No, I mean it's their data collection.
That's what I figured.
Yeah. So
it's not like you guys agree. All right, this is going to depreciate every month.
They probably could interpolate the formula. Like if you decide to sell your car 3 months into its life, they probably have an idea of what they want to pay for it. Like, oh, if I take this formula and interpolate into the center of it, basically like a third of the way, or a fourth of the way, through the year, They could do that. I don't know if they'd bother to. They probably have a computer program.
Well, they probably don't do that. They probably just pay you what it would be at the year because they're cheapskates and no one likes them.
They're trying to make money, right? That's
we
what
don't
they do.
like them.
Yes, ma'am.
No.
Right here it just said your initial. They called it P in your book, but in your formula card they keep calling it N sub naught. It's just the initial amount that you invest. P stands for principal in money problems, but on your formula card they don't write it as P. They call it N sub naught, N sub naught, N sub naught. That is a good question.
Did you write the formula card?
I didn't.
Oh, okay. I just find it funny when
stole it.
Like anytime
I say like they.
Like, yeah, you
like
always
somebody
say,
else.
You always say they for
some
anything.
jerk.
And it's like, this is a loser. Didn't you write this?
No. I'd like to talk about myself in the third person. Okay, so on worksheet, flip to side 16B. And I want you to, everybody please, write down number 39, which is 3 to the x plus 3 power equals 27 to the x minus 2 power. There is a question just like this on your test. So, I noticed it's an exponential question. I also noticed there's 2 pieces of exponential in this equation. That's annoying. But I also noticed something special about their bases. We have a 3 and a 27. They have common bases. So we could rewrite 27 as a 3 by calling it 3 to the third. Yep, 3 to the third. So this is 3. I couldn't hear you. 3 to the x plus 3 power equals, and then Adam told me this is 3 to the third power, but it already had an existing exponent. The existing exponent was the x minus 2 power. Now, this is the only moment where I'm concerned. And it has nothing to do with your pre-calc abilities. It's just a sloppy mistake that I see sometimes from you guys. What is this exponent up here?
3x.
Thank you, because you're going to fully distribute that together, right?
Yeah.
Of course. So this is 3 to the x plus 3 equals 3 to the 3x minus 6, just like you told me. Now it's an easy question. In order for these to be equal, that means since they have common bases now, their exponents have to be the same. So we're going to set up x plus 3 equals 3x minus 6, and then don't make a sloppy algebra mistake. So let's see, that would be a 2x equals a 9, and x equals 9 halves. Yep. That's the same. Everybody needs to write down number 41. That says e to the 2x power minus 8e to the x power plus 15 equals 0. So there's a question just like this on your test. And it might help you if we rewrite e to the 2x as e to the x squared. Maybe now you can see what your teacher wants you to do. I don't really like handling quadratics that use e to the x power as their leading terms. That's kind of confusing. So we offered you guys a bit of a, it doesn't seem like a shortcut, but it's basically you're making your problem easier so you can handle the factoring, and then you'll come back and bring back the e to the x factor. So we're going to do what's called u substitution. Let u represent e to the x power. So then, I'm going to take my work down here now. This becomes, instead of e to the x power squared, that becomes u squared. And then minus 8 times u. And then plus 15. Now that we can factor and solve like in our sleep. We're good at these. So we get u minus 5 times u plus 3. Nope, minus 3, Abruzzo. It's just getting all cocky and then I screwed up. All right, u minus 3. So you got u equals 5 and u equals 3, and then I make a statement that bothers everybody because I come back and I say, I don't even care about you. I don't mean that. But I don't care. Because u is not really a part of this problem. What did u represent again? This is really e to the x. So this says e to the x equals 5, and this says e to the x equals 3. That I can solve.
No, natural logarithm.
Natural logarithm would be brilliant. So on your test, it's going to ask you first to give the exact answer. So this cancels, awesome, and this becomes x equals natural log of 5. That is the exact answer to that factor. So then this guy would be x equals natural log of 3. That's the exact answer to that question.
Because it doesn't look like it's exact. If you
Well,
know it is exactly it, like,
No.
I'm
It seems like
also,
you're cheating. It's not
well,
like
here you
cheating.
go, Daniel. I'm also going to ask you to give me a decimal approximation rounded to the hundredth place. So
that's
now-
three decimals.
Two place values. So natural log of 5, guys, what do you get? I need you to, I don't know that. You need to type that. I'm not like a super nerd, sorry.
Yeah.
Yeah, you kind of are. What if I did like, no, yeah, I was not going to go with that. So we're on to 1.61. And then natural log of 3.
What? Oh, that's
1.10.
all right.
1.0.
So 1.10 if I go to the hundredths? Okay.
Or 1.
To the hundredths? To the hundredths.
Where's
Oh,
1.1?
child. Okay, now, what if, and this didn't happen this time, guys, but just pretend with me. What if I got to this stage of my factoring, and it was like x minus 5 times x plus 2 equals 0, or u, excuse me, not x, u. And then I went to go set this up, and I was like, natural log stuff coming up. Okay, so you got e to the x equals 5, and e to the x equals negative 2 when you solve those, right? Oh, I heard a big no. What? Okay, this one right here is the problem, right? If you tried to apply the natural log on the next step to a negative 2, I mean, you'll figure it out really quick. Because when you go to try typing it in, your calculator is going to spit out an error at you. When you go to apply the natural log to the negative 2, you can't. It is undefined. Logarithms are not defined. Are you wondering what my scribbles say?
I have no idea where we are.
I just made up this problem.
Oh.
Okay. So this question, this side of the equation, that one you do get, x equals natural log of 5. Lovely answer. Keep it.
You're not
But-
recording.
What? I was so
I couldn't see
recorded.
it, so.
Well, I'm sorry. Now the internet will know.
Well, usually it shows up at the bottom.
I
so.
know.
What's the most interesting thing you had happen while you were recording?
When I record at home, my children like to mess with everything, apparently. And my daughter has a video, I think it's my factoring video in Algebra 2, where she is standing behind me and mocking me for like 10 minutes.
You didn't know?
Well, I knew she was back there. I thought she was just like being cute. And it turns out, no, she was making fun of me. There's another video in that same area of Algebra 2 where my son is screeching because there's a bug in our house. And I just ignored him. And then there's another video that I deleted for obvious reasons. My son came running in naked. So that got deleted quickly. Because I didn't know how to edit. So I was like, well, I guess I'm starting over again.
Well, you deleted it before you...
I just quickly got rid of it because I thought, I don't know how the internet works very well, so I'm just going to quick undo, delete, not save, go away. Yeah. Kids are great, aren't they? Okay, so let's take a look at...
I have a few of my own.
Okay. Let's look at 53. I believe there's a space for you to do 53, right? Please don't write down this entire problem. I just want you to write down the math with me, okay? So we got Delson, which, what a name. Delson. Sorry, Delson. Your parents like you to be picked on. All right, has $8,000 and wants it to increase to $12,000 in an account. He needs it within 5 years, so cool beans. All right, so he found a bank account that offers a 6% interest rate. And it's continual interest. See the little word snuck up there. And they want it to reach 12,000, remember. Okay. So we need to set up a PERT formula. So this is a case where you know what you want your answer to come out to. So we're going to start our formula with 12,000 is what I want my answer to be. But we're going to start with only $8,000. And then PERT is a base E. And then investing, meaning it's going to grow. So a positive 0.06 times a mystery number of years. So, in Algebra 2, you guys got away with, like, approximating based on the graph. That's not going to work for PreCalc because you guys can solve this just fine. So, we're going to start by isolating the exponential. So, divide by 8,000. This is like a really small version of the math we did on Newton's law. So, this should be like a cakewalk to you now. 12,000 divided by 8,000 is 1.5. I believe.
Yeah.
And then e to the 0.06x power. So, now I know I have to apply a logarithm, but one of them would be a lot smarter than the other. This is a natural log question. So if you apply a natural log to the left side, it's just kind of icky. But on the right side, they cancel. So you have the natural log of 1.5, which I'm just going to keep writing down like that, equals 0.06x. So one last step here to solve. You're going to divide both sides by 0.06. How long does Mr. Delson have to keep his money?
6.75 years.
Is it exactly that? 6 point? What? Give me a fairly decent decimal, because, I mean, why would we do all that math?
6.75775.
Okay, 6.76 sounds good. Years. That works for me. All right, so the point being, we have the algebra skills to solve that as accurately as my teacher requires, I guess is my point. All right. Let's take a look at now worksheet 17. There's a lot of good questions on worksheet 17. So, where to go? There it is. Let's start off with number 3. This time, we're cooling a pie. Yes, I'm assuming. There we go. It's just whatever.
They should have.
I gotta make something for Thanksgiving.
You know, they should have called it a pie, and it comes out of the oven at 314 degrees.
That would have been a great problem. Oh, that would.
Can you write one that's just it's pie all throughout? All the
That's
pie-
kind of
it's
awesome.
ton
That's
of
like a
pie
super
numbers.
nerd problem. You get author credit for that one, okay?
Thank you.
That's awesome. All right. So this pie, not PI pie, but whatever, works too.
The oven was running low, so you had to put it in for 31.4 minutes instead of 20.
Oh my gosh. The fact that, what a nerd. I love it. Okay, so the formula that we're giving to you here on this page is actually, I think, the same one we give to you on the test. So one thing you might notice is a little different. They use temperature sub M, representing the medium, instead of temperature sub S, which is surroundings. They mean the same thing, though. So here, the 350 degree oven, this was the initial temperature when it comes straight out of the oven, the first part of the problem. And then it cools down to 115 degrees. So this is the temperature for the final part of the first part of the problem. And then after 20 minutes, so there's T, time. And then the temperature of the room is what's known as the medium or the surroundings. So 70 degrees is the temperature of the medium. We're going to do 2 parts to this question. This looks just like your question on the test. So it would be helpful to your teacher if you kind of break up your work a little bit. Just remember that this part here, this is for part 2. Don't use the 98 yet. Part 2. Here we go. All right, so temperature final. In the first part of the problem, the final temperature was 115 degrees, but you're going to subtract the room temperature, which was 70, equals, make sure this part's in a parenthesis set, your initial temperature for the first part of the problem, actually both part of the problems, is 350, minus the medium again, which is 70. And then it's multiplied by e to the negative kt power. So for us, that would be negative 20k. Why is it negative? Because it's cooling. Yeah, it's negative in the formula, but it's negative in theory because it's cooling. That's fine. I gotcha. All right, so now I think if we want to practice this like we're going to do it on the test, then let's do that. I would suggest everybody not throw everything into your calculator at once. Maybe a little bit of stages. Like, for instance, 115 minus 70 is 45. And then 350 minus 70 is 280. Now, I gotcha. I know a lot of you start taking shortcuts from here down because you see what's going to happen next. You know you have to isolate the base, so you divide by 280. And then this is sometimes a really nice decimal and sometimes it's horrendous. So it's horrendous, okay? So I'm just going to write down 45 over 280 and not even bothering to type that part in. Because what's going to be my next step? I'm going to apply a log. Which type of log?
Natural.
Yeah. And then after I apply the natural logarithm, what's going to be my final step? Because these are going to cancel. Yeah, and you're going to end up dividing by negative 20. So if I was on my test, you know, I don't really want to take so much liberty where I end up getting it wrong and can't afford a good score because I didn't show my work. I might write down this step. Just to be safe, so my teacher knows I know what I'm doing. All right, and then, yes, you guys are right. You are dividing by negative 20. So your k values in these problems should always come out to positive, generally tiny decimals. What did you get?
0.091406.
I'll stop it right there. 0.0914 sounds pretty darn accurate. I mean, it's a pi, guys. I don't know how accurate we have to be. And it doesn't state how accurate. I just would caution you that show your work and don't round too much.
Why wouldn't k be negative?
The negative is part of the formula. Like, it's already interpreted into the formula as being a cooling constant. So in your math, the k value comes out positive. That's a great question.
So, what is it? What does k represent?
It's the constant of cooling for that particular thing. So pumpkin pie, whatever it is. How does one determine that? By this. You take a data point and you find k. All right, so for part 2 of the problem, we go back to that question, but we change the final temperature to 98 degrees. And then we also switch k for 0.0914, and we don't know time this time. So now my final temperature is 98, while everything else is the same, except for k and t. So, the good news is, oops.
Didn't we do the first part?
No. What do you think we did wrong?
Because don't you have to start out the problem from the
What do you think we should change? Let's start there.
feels
Spit it
like
out, Dean.
The over on the left side.
Okay.
That shouldn't be 115 and 70. Why isn't it the 350?
Final temperature minus room temperature. So the final temperature after sitting out in the air for 20 minutes was 115 degrees. Okay. All right, so this one actually the decimal's not too bad. So if you just wanted to divide 28 by 280 and then write down the decimal, you can. But if you're like, you know what, I just don't care, because you know what your next 2 steps are. You know that you're going to apply the natural log. And then what's your last step going to be? Dividing by negative 0.0914. Now, if this is what your work looked like, I actually would totally be able to follow that. You guys are more meticulous than that, though. So, especially on a test. Maybe you don't want to be that crazy. What'd you get? It's like 25 minutes or something? 25.2 minutes. Sounds good. I mean, again, it's a pi. If you're off by a little bit, it'll be okay. Unless you're on Top Chef. Or whatever those... Master Chef. Top... What's the other one?
Top Gun.
No.
Top Shot.
Okay. I'm just going to pause and read this question and see if second hour can catch on to this. First hour, we had a good time. The number of fruit flies doubles every 8 hours. How long until a single fruit fly produces a population of about 1,000 flies? Thank you, Adam. I'm like, okay, I don't know how fruit flies produce. Maybe they're just born with little fly eggs. I don't know. How is a single fly going to produce anything?
Well, it's already pregnant. It was already pregnant, and it flew away from the nest and it's by itself, and it's making
Because
a new
first
one.
hour, we were
Because
very
she's an
alarmed by
independent
this
woman.
question because we were wondering, how does a fruit fly do this? And we were a little stuck on that. But we got over it. We did the math. Okay. What I want you guys to do, this is on your worksheet, right? Can you change it a little bit? Because I want this to reflect what you're going to see on your test. How long until the fruit fly produces to a population over 1,000 flies? And then write a little note here to the nearest tenth. Well, I shouldn't write it that way. Let's write out the word tenth. You get confused later, I bet. Okay. First of all, this question's a lot harder than it looks. Okay? Awesome. I'm up for the challenge. Thank you. Don't worry, I got like 3 of them after this. We can keep practicing them, okay? First of all, you need to set up your formula. So the formula on your formula card that you'd be checking out is this guy, where it says n sub naught times r to the t over h power. So N sub naught always stands for initial. How many flies are there initially in this kitchen? There's just one little fly. Some magical pregnant fly. This independent woman fly you're telling me about. Okay. Rate. Guys, now read carefully in the question. This is not meant to be hard. Just think about it. What is the rate that it's producing? It's doubling. So what do you put down for R? Thank you. It's a 2. Doubling means rate of 2. Now the T is what I don't know. Oops, wrong color. And then you're supposed to divide by how often the population doubles, which they did tell you. It is 8. And your answer is supposed to come out to 1,000 disgusting little flies. Okay, your job is to solve this. And this is a case where all of your math knowledge and rounding knowledge is going to counteract with what is known as logic. Well, look to the nearest 10. So we gotta be careful here. Now normally, if there's an initial value here other than 1, I would have you divide that over, but we don't have to divide a 1 over, so I'm not gonna worry about that. So let's go ahead and apply a logarithm. Do you want to use a common log this time to shake it up? Sure. All right, so apply the common log, and while nothing cancels on the left-hand side, the exponent does come down. So t over 8 times the common log of 2, some gross number. It's not that bad, actually. This is actually a beautiful number, though. Log of 1,000. I mean, you could just write it down as log of 1,000. Yeah, it's just a 3 because it's base 10. Okay, anywho, we're going to solve. We're going to divide both sides by common log of 2. And this one, I would like you just to kind of tell me what you get here. What's common log of 1,000 divided by common log of 2? Yeah. Okay. Oh, dang it. See, disaster. We're going to be so off. Okay, 9.9.
657.
No.
Is that okay? All right. I was like, eh. All right. So one more step, though. We still have to. How about multiply by 8? There we go. Okay. So if this was just a robot math question, and my teacher said round to the nearest 10th, I would write down t equals, this is what? 79 point. So I'd round to 0.7 because it says 10th place, right? I'm going to be like, la-di-da, 79.7. Here's your answer. Boom. Stop. Plug that number back into this original formula, this fruit fly formula, okay? If you were to plug in a 79.7 right there,
you would not get 1,000.
You don't get 1,000. So this is a case where in math, like your rounding rules that you learn when you're a 3rd grader, usually make a lot of sense because we all have to agree how to round. But it doesn't make sense when there's a real life application sometimes. If you round this only to 0.7, you haven't had enough time go by where there's enough fruit flies. You're only at like 900 and something.
997.
So we say, forget your rounding rules. We're going to have to round this up to 79.8 hours because that would be the next 10th. My teacher did request I round to the nearest 10th. So can you plug in a 79.8 there? And then you get like round to the nearest whole fly. Is it like 1,006? Yeah. All right, cool. So then here's the follow-up question. It's going to say, once you round to the nearest whole fly, how many flies over 1,000 are you?
6.
Yes, 6 over. Okay?
So that's why they wanted to go with about 1,000 flies to begin with.
Right, but I changed the question because of what's on your test. Okay? Because I wanted 1,000 flies, and the question's going to say, how many over the mark are you? And you're 6 extra flies. So the point of this question is rounding makes a difference, right? Even a 1/10 of an hour longer, all of a sudden you got a whole bunch more flies you weren't expecting. So if you were a scientist and you were trying to incorporate some real-life data, you got to be careful about your rounding. All right, this question... I'm thinking, yeah. All right. So guys, this question looks a lot like the one that's on your test. So it's a little more explanatory. This is not anywhere on your worksheet. Can we just walk through this one together? Okay, so
Isn't that assuming that every fruit fly that they have is also able to reproduce?
Yeah.
Because if they have a boy...
I don't know how fruit flies produce. Maybe
okay,
they're like amphibians. I don't know. They're not anything like frogs, Bruzo. I don't know. Go ask Berryman. You find out how fruit flies produce. Because you killed them? Oh. Oh. Do you still have to do like pigs and cats and stuff? Oh. Oh, I don't think I could do that. Oh. Yeesh. She's out. Okay. We have a single cell virus. Okay, I feel better talking about virus cells. I don't know why. Because I just assume they produce. I don't have to think about it too hard. Okay, so every 3 hours they will double. 50 such cells are placed in a host, and then we calculate the amount of time it takes for the population to grow over 25,000, okay? It has to reach over 25,000. Keep that in mind when we get to the end of this first part. Okay, let's set up our equation, guys. So we need to get to 25,000, or over it technically. And then I heard Adam say we started with a 50. Okay, why are you going 2, Adam? Because it's doubling. Very good. What about up in the exponent? No. How about t over how often does it double? 3. There we go. So when I ask you for what equation did you use, that's what you'd write down, or something to that effect. Okay, now it's time to use our algebra skills to solve it. We're going to divide both sides by your 50. And I should be able to do this. Let's see, that's 500. Is it? Because I'm often misusing decimals. Okay, it's time to apply your logarithms. Which one do you want to use today? Fine. Whatever. Okay, so nothing cancels, which is fine. But the exponent does come down. That's the whole point of the logarithm. So I don't have enough space. I'm going to start writing over here. I have the log of 500 equals t over 3 times the log of 2. So on your calculator, guys, I need you to do these calculations for me. Go ahead and divide by the log of 2. And then I also am going to need you to multiply that answer by 3. Yeah. And then round to the nearest tenth of an hour. What do you get? 26.9. 26.9? Okay. Now, I'm paranoid because we just had a problem with the fruit flies where my normal rounding wasn't going to cut it. So what I need you to do is now take the 26.9 and plug it into this formula and make sure that we're over 25,000. Because if we're not, we have to adjust it.
25.
So we're over?
Yeah.
Cool. All right, so we get to keep our answer of 26.9 hours. We don't have to do any fancy rounding other than our normal rounding. So we would have lucked out if this was our test question, if we forgot that rule. So now the question continues on, and it says, after rounding to the nearest tenth, calculate how many cells over 25,000 you really are. So Adam did that for us. He took the 26.9, and he plugged it into this formula. And you got round to the nearest whole cell here. What do you get?
251, scratch that, 0, 1, 5, 0.29.
Okay. So round to the nearest cell is right there. I keep hearing 50 from you, and I was like, it's because Taylor had her 50 mark earlier. And I was like, what are you saying? Okay, so don't write down 25,015.
15.
It's 15, because they just want to know how many cells over you are. Okay? 15. That's okay. If that's the nearest... Okay, here's what you guys got to be careful about. You got to follow the directions. So when I say round to the nearest 10th, you round to the nearest 10th. Okay? Not the 100th. It has to be the 10th, okay? And if you plug it back in and you haven't met your mark yet, you got to round to the next 10th. Even though I know math doesn't tell you to do that, logic does. Okay? So that's the kind of question you're going to see on your test and you got to watch out for, alrighty? Do you want to try another one of those? Okay, I think those are good ones. So again, it's not on your paper anywhere, guys. Just walk through it with me. We've got bacteria this time, but they're dying. Okay, it's halved every 6 hours. So it's not that it's kind of, yeah. They want to have an answer of under 800 bacteria. They're going to start with 20,000 bacteria. And then what are you going to use for your rate if it's being halved? You're going to use half, yes. And then it happens every 6 hours. So your exponent is t over 6. Very good. All right, so there's your setup. Your work is just your work. So you're going to divide both sides by 20,000. Hey, be my calculators, please. Thank you. I need you still, because now we got to do logarithms. I need you guys to apply whatever kind of logarithm you want. Basically, you're going to do a dividing and multiplying problem. So on your calculator, you need to do the log of 0.04 divided by the log of 1/2, or 0.5. And then you got to multiply that baby by a 6 because of this t over 6 thing. So to the 10th place, it's 27.9. But wait, I don't know if that's actually going to work. So please, go back to your formula, plug in a 27.9 exactly, and tell me if we hit the mark of under 800. So we're under? Cool. So I'm going to use the answer of 27.9. What is this, hours? Okay. And then, when you guys did plug in 20,000 times 1/2 to the 27.9 over 6 hours, you guys got what? When you round to the whole cell, 796? Is it round up to 7, Adam? What's the decimal? So yes, it rounds up to 797. Rounding is importante today, guys, okay?
Yeah, but you just told us to round differently.
When logic dictates. Okay? It would only round differently up in this question. If you didn't hit the mark of under 800, you'd have to round this to 28.0. Okay? So, guys, don't put 797 here. The answer is 3. You have 3 less bacteria than you were planning. Okay? Woo! What? I don't know. Maybe it's that good bacteria. Alright. Let's see here, guys. The TVM solver stuff is coming up. You might want to jot this. Is this on a paper anymore? Yeah, it's on 17B. It's number 8. This is a question where you need to use the TVM solver. And the order in which it asks for things, it goes, it starts with N. So it says N equals, and then I equals, and then present value, and then payment, future value, and then payments per year and compoundings per year. Okay. So, what do they want when they say N? Has something to do with 25 years and monthly, right? So monthly times years. That's what they want. Now, interest, this is where you got to remember on the calculator, they don't want you to change that. You're just going to write down 4.25. This is a mortgage question, so your present value is the amount that you take out from the bank. So that is your present value. The payment is what you're actually trying to solve. So I'm just going to kind of leave a box here and remind myself I'm going to solve. By the way, you do that by hitting alpha enter. Future value should be nada because you want to pay off your loan. And then you're going monthly for both of these, so 1212. So you get all that data entered. And then are you calculating it for me, Daniel? I need the mortgage payment. Adam, go ahead.
Negative 920.9547.
920.95 cents?
Yeah.
Okay. So that's your mortgage monthly payment every month. Then they also want you to find how much money you end up paying for the house itself. So you take that $920.95
Multiply it by 3.
and you multiply it by 12 times 25, which yes is 300. Because monthly payments for 25 years. How much did you pay for this house, people?
$276,286.43.
Nailed it. Well, it's not stupid because you get to sell your house now.
That's $106,000
In interest. So we want to think about ways to save on interest.
Pay in cash.
Well, that would be beautiful. Do you have cash laying around? My goodness.
I'll save
Are
it
you
up.
taking adoptions?
I'll save it up.
Yeah, that would be quite awesome if you guys could walk into a house payment with a huge amount of the money down. Yeah, that's quite cool. All right.
That's my goal.
So here's what I need from you tonight. Shore up all your homework and look at the review. I will not have time to go over the whole review tomorrow, so you got to tell me exactly which questions we got to look at. Okay?